Hey, and welcome back to the channel. Today, I will show you how to solve word break interview question from Leetcode. This question has been mostly asked by Facebook, but it also has been asked by various other companies like so. We will use JavaScript with a BFS solution by leveraging an array as a queue. Also, there will be another video about dynamic programming solution as well in the near future. Before we continue, make sure to like, subscribe to the channel, and comment below and give me a feedback. It's highly encouraged and appreciated. Now, without further ado, let's dive in. Here comes the problem. Given a string s and a dictionary of a string, word dictionary, return true if s can be segmented into space-separated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in a segmentation. Let's see some examples. Here are the examples. For first example, we have Leetcode as an input string and leet and code as words inside of a word dictionary. What we need to make sure is that basically to see if we can break our string using the given words. So in this case, seems like we can, because if we use both leet and code, we can create the given Leetcode string with one space in between, and there will be nothing left from given string. Second example basically is the same. This example just wants to notify us that we can use words from dictionary multiple times. As you can see, the result is true, and there are two apples used in this case. Last example, result is false because if we use words from dictionary, we only will be able to succeed to create some part of the given string, not all. Let me show you. So we have cats and dog here as a given string. One possibility is to using cats plus dogs, but there will be an and s left out. Second possibility is using cat plus sand, but in this case there will be ogs left out. Last one will be using cats plus and, but again there will be ogs left out. So this example exactly clarifies what the problem asks for. We want to segment the given string in a readable format with spaces only using given words, and at the end nothing remains. Let's think about how we are going to solve this problem. So the brute force solution could be something like checking for each value from dictionary, and maybe if we found something that matches with some part of our string, we will remove that part, and at the end if there's nothing left from given string, that would mean we can break this word using dictionary, and if not, we can't. So as of our first attempt, we will check for cats, then we have a match here, so we will remove it. Let's try it one more time for dog. Next word in a row. Check first, we find something, we remove it. Now as you can see, there are 3 letters left in this case that does not match with any other word in the dictionary. Let's move on to another word combination. This time we won't use the previous word, just for trying something new. Let's check for cat without s, we have a match for it, remove it. Another new word, sand, we have another match, then remove it. Now we left with ogs, which there are no match for it in the dictionary. Moving on to the last combination check, let's try cats with and, the last word that we haven't used before, and see what happens. So cats, match, remove. Second one, and, match, remove. Again, another leftover from input string. So literally we can't break this word with given dictionary of words. We basically can code that, but first, usually we don't want to mutate or change our input values in algorithms, and second, for that solution, we need to do a lot of iteration and search over both string and dictionary, which does not sound efficient enough. So there has to be a better way. Let's explore. Let's imagine our second example that we might return true for it. I need true case to show you the process. So what we are going to do is a search idea originated based on the input string, not the words in the dictionary. We need to search every possible range of words from our input string, and if there's a match, mark it and continue looking for another potential word from dictionary. In this case, let's think about a range of words indicated by 2 variables, start and end. They cannot both be at the same index, so end pointer has to be at least to the next index from starting point. For each range of letters that start and end pointer will give us, as we traverse over our input string, we are going to check our dictionary to see if it is there. And if we can't find any match from dictionary for our current range, we have nothing to do except expanding our range one by one and search again. If we happen to finally find a match from a dictionary, like the apple in this case, okay, that sounds good. We will save that index for next iteration, where we will update our starting pointer to start from that point we found. But that's for next iteration, and we haven't finished our current one. So let's continue, and as you can see, there is no possible match until the end of this iteration. But for next iteration, we already know where to start. We saved it right here in our storage. That means if we ever find a word, we will ignore that part of a string in the next iteration and jump forward as long as that word we found and start from there. Do the process again and again until we finish the iteration of our string. So as you can see, we shifted out first item from our storage and started from there this time, index 5. And as we continue in our lookup, we will find nothing until this index here, index 8 of our string. We have another match from our dictionary, pen. So we will push its index into our storage and again continue looking for more. Like before, until the end of this iteration, there will not be any match from word dictionary, but since already we have found a match, the word pen, for the next iteration, we know where to start again. Yes, you are right. Index 8, the last number that we pushed into our storage array. So we will shift it and start looking from that index. As you can see, if we do a quick iteration like so, we will face with another word of apple. So one last iteration will give us another match as soon as our end variable reaches into the last character in the word, end of our string. But before we updating our storage, I want you to think about two things. First, we found our last match. Second, we are literally at the end of our string. Our end variable is at the last character, and even if we update our storage and pick up end index as next starting point, there is literally no place to go. This is the point that we know that we successfully broke down this word, and there is no need to update our storage at this step. We can just return true from here. Now, there are two things before jumping into the code. First, as you might have noticed, I've used different colors for first apple, pen, and second apple. That was only because I wanted to show you how this breadth first search works. Of course, BFS is so obvious and clear in the tree-shaped data structure, but the only way that I could explain it was like making your thought process to accept how we traverse all possible combination for each starting point that we found. There will be more videos on channel about these methods of traversing, and I'll do my best to explain it as simple as possible. So make sure to subscribe to the channel for those videos too. Second, I want you to focus on this storage that we had and how it actually worked in our case. We needed a special mechanism over array for handling our situation, which has been called a queue. For now, just note that by special mechanism, I mean we always only pushed items to the end and shifted items from start of the array. By that mechanism, we can have small and quick version of queue in our hand in JavaScript. This is basically how queue works in a nutshell, but keep in mind that the real queue data structure has other methods as well. Now, let's jump into the code. So here we are in Leetcode. First, we need to create our queue. So we will do an empty array, like const queue equal to empty array. Then we need to iterate over our queue because our entire algorithm relies on this queue, since we are supposed to push whatever possible breaking point or indices into it. So we will do while as long as queue.length is a true C number, we will do some stuff here. At this step, first, we need a way to trigger our main while loop because all of our logic will be placed inside of it. So we have it by using queue's length. On the other hand, we will start from index 0 to iterate over a string because we need to start from beginning of it. We need to push index 0 into our queue by default. And that is why we actually glue this while loop into length of our queue. So we will do 0 here. Next, inside of this while loop, we are going to take the first starting point from our queue, which is 0 at the beginning. So we will do const start is equal to queue dot shift first item. This will give us the 0 as a starting point. Then we will do another loop for input string, but this loop is only responsible for our end pointer because we already got our first pointer from queue right here. So we will do for let end equal to start plus 1 and less than equal to s.length and end plus plus. Remember that I told you end and start pointers could not be overlapped, and end pointer has to be at least next next to the start pointer, that +1 will do the job here. Okay, moving on. Now, inside of this for loop, since we have both start and end points, we can slice the part of the word that we want. So we can do const word s.slice starting point to the end point. That's the word that we need. Now, we need to check if this sliced word exists inside of our word dictionary. We need another search, so we will use array.include. If our dictionary.include the word, if that is the case, we need to do two things. First, we need to check if our end pointer is at the same index as our string length, because if so, then we know that we finished our iteration and can't break this string using our dictionary. So we can return true in this case. Second, if that is not the case, we will push our end pointer's index into our queue, because next iterations has to be aware of it. That is the point they need to start. So we will do if end equal to s.length. We will return true here. And if it's not the case, we will push the end index into our queue. At the end, if we finish both loops and could not find anything, we can say return false, indicating that there are some leftover characters that could not match with any words from dictionary. Now, if I run this will pass all of the test case, like all of the smoke tests before submitting. But there are two things before the real submission. First is the way that we look up for words inside of our dictionary using array.include. Array.include in JavaScript has O of n time complexity, but we can improve that lookup to O of 1 constant time complexity by using a set. So we will create a set of word dictionary. So we will do our dictionary is going to be new set of our real dictionary, and then check from our set in order to see if it has the possible match for our word. And if I run this again, everything is passing. Second thing will happen when we submit. So if I submit, seems like there's a super weird test case that causes our algorithm to throw a time exceed error. Let's wait for this guy here, this test case. So let me explain in depth that what is happening in this case. Here we have our long string like that. Here is our dictionary of words, basically starting from 1A to 10A's at the same time, or string to show you the process, and here's our queue. So what is happening in this case is a bit overkill, but my guess is that the Leetcoders put this test case here just to teach us something really minor about caching and memoization. So in this test case, what is happening is if we start from index 0 and index 1 is our end pointer, we will get an immediate match. So we will put our end index into queue and move on to search more. Another match, and another match until we reach into the index 10 of this long string. Now we will continue to search more and basically check for what we have more than 150-60 possibilities here, but we have nothing that matches with any word from dictionary. So in the next iteration that we do over our queue, we will pull out first element by shifting whatever we had in our queue. We get our new starting point, index 1. Now starting from index 1 ending in 2, we have a match, so pushing 2 again into our queue. Moving on, another match until index 11. We do still push those indices to the queue, and this is the important part. Then finishing up those 150-60 checks without any match. Moving on to shift 2 from our queue and doing the same cycle again, which will add this amount of indices into queue again. Same thing happens for index 3, 4 and others, but you get the idea. We are literally flooding our queue in this special case. Now imagine how much work we need to do in order to make our queue clear and empty, while each number that we shift out from our queue and we do the cycle, we literally add 10 more items in it. We definitely want to prevent this behavior, right? We don't want to check again for the same items that we already did. So the key here is to have a visited array, or preferably a visited set, again because of O of 1 constant lookup that sets brings to us, and check for starting points before we enter to our for loop. Actually, that was the reason we had time limit exceeded error for that test case back in the Leetcode. So let's implement this caching. Now, what we need to do is create a visited set, like const visited equal to new set, which at the end of each loop, we will push our starting point to it. Like this is our for loop. At the end of each for loop, we will do visited at start like that. But the actual rule, in order to prevent flooding our queue, is to check for starting index up front. So we will do if visited that has start, but with the exclamation mark, indicating that if it doesn't has that, let's do all of this logic inside. And before running, I want to mention that I've already added that special test case in our smoke test. So let's see what will happen if I run this code. And as you can see, it passes this special test case too. And we can submit at this step, and we have a good space usage in here. Now let's jump into the time and space complexity analysis. For time complexity, we will have O of n in power of 3 because we had a while loop for q, then we had a for loop over each string, then we were using array.slice method, which has O of n time complexity by its own. So all were nested, then our total time complexity becomes O of n in power of 3. For space complexity, it will be O of n, where n is the length of q, and at the worst case, q can take up to the length of the given string for indices. With that, I can say that was it for this video. Also, there will be another video soon about dynamic programming solution for this problem. So make sure to subscribe to the channel in order to not miss that one out. I also will put the link for string playlist in the video description where we go through solving string problems from Leetcode. So thanks for watching, and please like, comment and subscribe to the channel. And finally, hope you enjoyed this video and stay tuned for the next one.